Okay, so we're going to go ahead and get started with passage 1.2. We'll do one question at a time here. So we're going to start with 7. So which of the following can most reasonably be inferred from diagram 1? So that means my locator is diagram 1. And it says which of the following, which means that I need to read the answer choices first. Okay? So an increase in plant photosynthesis would decrease atmospheric carbon, while an increase in animal respiration would increase atmospheric carbon. So I'm just going to make a note on the side here that says increase in photosynthesis, decrease carbon, an increase in respiration would increase carbon, and see what I get. Okay, the next one, another option I have is the opposite of that. Decrease and decrease, and decrease and increase. So A and B are opposites of each other. So I'm going to write that they are opposites of each other. An increase in plant photosynthesis would decrease one increase in An increase in plant photosynthesis would decrease atmospheric carbon. That's like an answer choice A. While an increase in animal respiration would decrease atmospheric carbon. So I have increase, decrease, increase, decrease. And this is the opposite of that. Decrease, decrease, increase, increase. Okay, so let's see what happens. Let's go to photosynthesis first. In photosynthesis, green plants turns to carbon. So if I increase photosynthesis, that's going to increase carbon. Now if I increase the respiration of animals, that is going to, it looks like, let's see, increase the respiration of animals. That's going to lead to carbon in the air and water. So that means that's also going to increase. Cool, cool. So it looks like my answer choice is A. If you follow the graph, increase leads to an increase that way. But then if I increase my photosynthesis, that's going to go to the animals and decay. So what's going to lead us to this? It's all a cycle. So my answer for number 7 is A. All right, number 8. So number 8 says carbon fixation involves the removal of CO2 from the air and the incorporation of carbon into compounds. Carbon fixation can form which compounds? Okay, so let's see. We remove carbon from the air this way, and now we get greens, plants, carbohydrates, proteins, fats. So green plants, carbohydrates, proteins, and fats. So let's look at our answers. 2 only. We know it's not 2 only because we do have fat and protein. 1 and 2 only. It mentions fat and protein, but it also mentions carbohydrates, and carbohydrates is a starch. 2 and 3 only. No, because it mentions fat. 1, 2, and 3. The answer is J. Because it mentions carbohydrates, that's your starch. Think like potatoes, proteins, and fats. So it mentions 3 things, so we need 3 answer choices for A. All right, number 9. So suppose that scientists discovered a group of organisms that can impact the carbon cycle in a manner similar to plants. What effect would this have on the model presented in diagram 1? So let's see what plants do. So, in here, what do our plants do? So, plants are formed, they're digested by the animals. Animals put carbon dioxide in the air, and then that goes back into the plants. And then additionally, plants put carbon into the atmosphere. Carbon compounds of plants and animals decay bacteria, ferments, puts carbon in the atmosphere. So if we follow along those ones, now we can compare to our answer choices. So, the number of pathways to increase atmospheric carbon and the number of pathways to decrease would both need to be decreased. The number of pathways to increase atmospheric carbon would decrease while the number of pathways would need to be increased. The number of pathways to increase would both need to be increased, and the number of pathways to increase atmospheric carbon would need to be increased while the number of pathways to decrease atmospheric carbon would need to be decreased. So we have a new group of organisms that are doing the same thing in plants, right? So in order to keep the balance, both of these things would have to be increased, right? If you add an organism, you're going to need to increase the pathway. That one's more of a common sense question than any strategy. It just knows you're adding something to an ecosystem. You're going to need more pathways to support it so you don't mess up that ecosystem. All right, number 10. Based on diagram 1, so I'm going to be looking again at diagram 1, that's my locator. Can the carbon present in an animal's body return to the atmosphere after the animal dies? So let's see what happens to that in this cycle. So we have a dead plant, right? So my animal dies, and now there's carbon in my dead animal. That's going to go decay into bacteria. That'll be fermented, and carbon dioxide is back in the atmosphere. So I would say my answer is yes. Animal dies, carbon releases decay bacteria, that ferments and putrefies. Carbon dioxide is released into the atmosphere. So I'm going to say yes, and now we're going to figure out why. So no and no, I can cross both of those off. So yes, because animals can engage in the process of putrefaction, and yes, because bacteria can aid in the putrefaction on dead animal bodies. So which one is our answer? Is it F or G? Now we need to go back to the diagram. So decay bacteria engage in fermentation and putrefaction, or animals engage in fermentation and putrefaction. So if I trace back here fermentation and putrefaction, that is coming from decay bacteria. That arrow isn't coming from animals. If that were true, then we would get this down here. Okay, so since that's not equal to fermentation and putrefaction, the answer here is G, right? And the reason why is because in the diagram, bacteria attached to the decay, or attached to the ferment line, not animals. All right, 2 more questions. Then we're done with this one. Based on diagram 1, a direct source of CO2 in the atmosphere is, so what's a direct source? So again, diagram 1 is my locator, direct source of CO2 in the atmosphere. So that means that we can go 1 away. So that looks like 1 away is animal respiration, the respiration of other animals, because we're just going 1 away. the fermentation and putrefaction of decay bacteria, the respiration of green plants, photosynthesis and respiration, that goes to it, that goes away from it, that goes to it. Cool. So we got, and I'm going to make a note, respiration, fermentation, and that's plants, animals, parasites. Cool. So let's see. The fermentation performed by green plants. No, because that was fermentation by decay bacteria. Nope, that should be decay bacteria to be true. The photosynthesis of tropical plants. We did not write that. Nope, it's not in our diagram. The digestion of plant matter by animals. Nope, that's not on our list. The respiration of animal parasites. Respiration of parasites is on our list. The answer to 11 is D. Alright, thank you for hanging in here. Question 12. What describes the relationship between animal respiration and photosynthesis? So let's find it. What does animal respiration do? So animal respiration puts CO2 into the atmosphere. So animal respiration leads to CO2 in the atmosphere. Now photosynthesis, let's find that. Photosynthesis right here actually takes CO2 out and puts it into green plants. So it does the opposite. So photosynthesis, that's going to subtract CO2. You see how the arrow here goes from the CO2 to the green plants? But then this one goes from the animal to the CO2. That means they're doing opposite things. So their functions are definitely not the same function. Animal respiration provides vital gases for green plants. That's a decent answer. I'm going to not knock that off just yet. Animal respiration prohibits photosynthesis. Well, one goes into CO2 and one goes out, so I'm going to say that's not right. And there's no relationship. This is a cycle. Everything is a circle. So if it says anything like this is a cycle, boom, that means that they're related to each other. So by process of elimination, the answer to 12 is G.